try to play with or try to explore is the primitive data types and prim data types and what's the other one? Reference data types. Cool. So apparently primitive data type stores values into memory, while reference data types or stores reference of value in memory or memory location. And I think that's called a pointer. Alright, cool. So the difference is that one stores it into memory and one is a reference for another. So one thing that I seen was that if I have, let's say, a primitive data type such as an integer, and I'm going to call this integer, and I'll just call it x is equal to 7, and I got another one, and y is equal to x. System dot out dot print 9. So if you print x, of course you're going to get 7 right there. So if you print y, you should get 7 as well. Y, you're going to get 7 as well. Now, why do you get 7? Because y is a variable, but it's a primitive data type. So that means that y actually stores the value of x, which is 7, into a memory location. So that means 7 is actually in a memory location, I think, and not the variable. I think that's how that works. So that means if I were to change y and make that equal to, say 20, x is not going to change. Just y is going to change. I didn't print it out again. So this time it should be 20. Second one is 7, and you get 20 because up here reference to 7, and then I changed it right there to 20. So only y changed it, not x, because y is a primitive data type, and it stores the value into memory and not a reference. And so the difference between that and a reference data type, like an object, we'll call this one not a string. We can use an array. And we'll call this nums. And nums is going to equal, nums x. It's going to equal this new int array. And we're gonna just put 3 values in there. Okay, fuck it, 2 values go in there. num x 1 0 is going to equal 7. Num x 1 is going to equal, call it 4. Cool. So I should be able to print this out if I remember how to print it out. System.out.print, I think it's like arrays dot string 2 maybe? To string. And this is going to be integer. I don't know if it matters. Guess that one. Num x. Cool, so I should be able to print that out, and I get 7 and 4 for num x. So I say num x is, I think in Java it's a plus and not. Cool, num x is that. So then I can get another variable call and call this one num y. And I'll say num y is equal to num x. Here's the thing about these variables is that this variable num x is not directly in the memory. The values are not directly in the memory. The values are going to a memory location, to a pointer in memory, and that pointer is going somewhere. I don't know where it is. I think it's going to like something like a heap or something. I don't know what the fuck that even means, but so this is going, so that means that this is going to a memory location, right? So when you put num y is equal to num x, that means that num y now has that same memory location, right? So I should be able to print num y. Well, it has the same reference. So this is just saying num y is equal to the same reference as num x. So I say that num y, and it should be the same thing. Cool. What was my point? Num y, since num y is equal to num x now, it's the same reference. What should happen is that num x should change. X should change because if I change y, x should change, because they're the same memory location. Or if I change x, y should change, of course, but if I change y, x should change too. So let's just say that, yes, right. So if I change y, x should change because it's pointing to the same memory location. So let's say I change num y, and I'm just going to change 1, and I'm going to change that one to 7. So what this means is, since num y is equal to num x, they have the same memory location. So anything that I change with num y, I'm going to change with num x because it's the same memory location. What did I print out? Why did I print out both of these? This actually should have been num y to print out for an example. So these out. It's still going to print the same thing, but just to show that these are going to be the same numbers. Same numbers, but now I change y, and I'm going to print y, and of course y should change. I'm just going to print y, not x. So I'm just printing out all y. So of course now this first, no, you should have 2 7s. About 2 7s there. And why you have 7 4 up here? I have printing on both of these are Y. And Y. That's because I changed it right there. 7. Anyway, cancel out on that. And they get 2 7s. So also the thing is now when I print out X, this also is going to be 2 7s. It should be 2 7s because Y, well, because Y is equal to num X and num X is equal to this right here, this array in memory, the memory location. So we're just talking about the memory location. So this has the same memory location. So if I change, so this and this are the same memory location. It's going to the same object. So when I change the actual object down here, and since they have the same memory location, they're pointing to the same object. Num X should be the same as num Y when I change it. And we'll print that and we should see 2 7s. 2 7 7s, I should say. Bow. Num X and num Y. Well, why does it say num Y? It just say num X. Num X. Not that it makes a difference, but num X. And that is because they're pointing to the same memory location. Can't draw on here. I wish I can draw on here. Yeah, same memory location, that's why. And that is different than this primitive value over here where they're actually the same value. So you got int X is equal to 7. Int Y is equal to X. So if you print out system.out.print X and Y, you get 7 and 7, 7 and 7. But if you change Y down here, you should get, well, X shouldn't change. Cancel these out. X shouldn't change, but Y should change. X is still 7, Y is still 20. While in this example, X and Y both change. Y, X, because I changed this and it's pointing to the same reference. So I could change this again. I could change this to a 99. And now X and Y is going to be 99. Because it's sent to the same reference. You're not changing the actual value, you're just changing, or you're changing the object value, but they're both pointing to the same object. So if you change one object, you're changing the same object. That's it.